Welcome everybody to this latest Streetside sessions. Today we'll focus on OXT's latest update called Fingerprint mode. This update has been something that we've been working on for a little while. We released a few weeks ago, and it'd be good for some people to see a little bit of a walkthrough and just know kind of where we're coming from and why we why we've put this out there. Why did we do this? Number one is a better UX for us as analysts. If you remember back to, I guess, maybe one or two Streetside sessions ago, I did a ransomware tracking, live stream of OXT. And I was having to jump in and out of the transaction graph to keep an eye on the fingerprint of the wallet that we were tracking. And that's a bit of a pain to do. It'd be easier to just display this on the graph, which is what we've decided to do, right? And if we can display this directly on the graph, we'll be better at tracking. We'll have better accuracy. We'll be less likely to miss a new wallet fingerprint, new software fingerprint, which can be a sign of coins either changing hands potentially, or at the very least, a new software being used to spend coins. And we've used fingerprinting quite a bit. It's becoming more common, I think. One of the biggest ones was identifying the custodial tumbler blender as it piggybacked off of Wasabi's coin joins. We picked up that very distinct fingerprint. And so, not only do we get better UX, we get better accuracy. If you guys are auditing your transactions, like we hope you do with OXT, you can get a better sense for just how bad things really are. What is the state of Bitcoin's default privacy? And maybe you don't need to understand everything that we're going to talk about in detail, but if we can just present this visually, even without totally understanding, you may be able to, understand just how bad things can kind of be. And the last thing that was sort of a motivating factor is kind of the research that we've been seeing coming from, academics, funded by the likes of Chain Analysis and others. And so, what we'll do first is we'll just review kind of what a typical transaction structure looks like. If you've never seen a Bitcoin transaction before, this is what we call a simple spend. It's got one input and two outputs. One of these two outputs is very likely to be change output that returns, the surplus from this payment back to the user's original wallet. And if we can track these change outputs, we can track a user over multiple transactions. And so one of the biggest ways that change is tracked is with a handful of heuristics. This heuristic is an example of the different script type heuristic, where we have an input with a P2SH from a P2SH address, starts with a 3, and we've got two outputs, one with a P2SH output, and another with a pay2 public key hash output. Because we've got a different script on the output side, we can deduce that first output that starts with a 1 is a likely payment, and the second output is a likely change back to the user. Another change detection heuristic that's used is the round payment amount heuristic. So if you look at the outputs of this transaction, you can sort of ask yourself, which of these amounts did the user likely type in input? Which of these was the likely intended spend? In this case, it would be the 0.17 BTC coin, which makes the other 6.5 and change output the change. And you can even see that OXT will apply the round payment amount heuristic to this transaction and tell us which output is change. And another one of the pretty powerful heuristics is the unnecessary input heuristic. So this is a spend with two inputs. And in this case, both of the inputs needed to be co-spent together by the same wallet in order to make this 9.2 BTC output payment, right? So alone, the 0.6 Bitcoin input and the 5.6 roughly Bitcoin input were not enough to make that 9.2 BTC spend, right? Which means we can deduce that the 9.2 BTC output is the likely payment, and the remaining output is the likely change. And this heuristic is also pretty powerful, and it's what we're seeing. That's just a handful of heuristics that are being used and leveraged to fingerprint users and track them. So here's a handful of things that can be used to deduce wallet fingerprint, right? Which does it have a preferred script type for spending? Does it have a preferred TXO, change position, lock time, version number, replaced by fee, etc.? All of these can be used to fingerprint a wallet. And so to get into kind of some of the research that's coming down the line, here's one paper from the Financial Cryptography Symposium, where two researchers from Princeton University have applied a machine learning algorithm to the Bitcoin blockchain data set in an attempt to what they call resurrect address clustering in Bitcoin. But what this really means is track a user over multiple transactions automatically. Can we detect change realistically, accurately enough on our own to do an automated tracking? In a similar paper, well, actually this one, this is a slide from that same paper that talks about how wallet fingerprinting and their heuristics have improved with time. So if we remember back to before SegWit was activated, there was really only one or two script types, pay to public key hash, and I think just pay to public key. When SegWit was introduced, we got a new script type, which this graph sort of implies has basically increased the accuracy of their heuristics. And one last paper to just sort of talk about here. This is the same as the same type of graph, same type of process as that 2 slides ago, where they're again applying a machine learning algorithm to the Bitcoin blockchain in an attempt to automatically track and cluster users over multiple transactions. These area under the curve numbers are relatively high. I guess maybe mathematicians will have to debate if that's high enough, but it implies that some of these machine learning algorithms have gotten really quite accurate. An area under the curve of 1 would be perfect. This one's 0.923. And so what does this mean for Bitcoin users? Without sort of sane defaults that are applied at the wallet level, automated tracking may be coming down the pipeline. This goes beyond just clustering by the common input ownership heuristic. Chain analysis firms may be planning to experiment with implementing some of these, machine learning algorithm results into their automated tracking. The second paper that I presented above actually discusses some of the fixes that wallets can implement. Randomized output positioning, like type scripts, and a few other things that can make these machine learning algorithms a little less accurate, right? And so now what we'll do is we'll transition to a walkthrough example on OXT to show you kind of how this looks visually on the graph.
Ergo, do you want to share a OXT link, a bookmark link, or something for anyone who wants to follow along on their own computer?
Yeah, I'll put one in after.
Sure.
I don't think you'll be able to follow along in real time, but and I'll basically drop. Maybe I can just do it right now. Drop some of these links that I just referenced into the chat. What I'll do too is I'll drop the transaction ID that we're going to start with, and people can follow along that way. Okay. Okay. So now we'll transition to looking at these transactions on the OXT, Explorer. One of the big questions that a lot of people have trouble with is,
I can't see your screen. I'm not sure if anyone else can.
No screen? Okay, I just switched. Let me see.
There we go.
How about now? Good?
Yep, you're good.
Okay. Okay, great. Close this. Here we go. So one of the things that a lot of people will have trouble with when they come to OXT, they're looking to access the transaction graph. A lot of people are used to plopping in an address as their starting point in their block explorers. In order to access the transaction graph from the address page, if you do it that way, you have to be signed into OXT. So one of the ways that I usually just start is by just inputting a transaction ID just to get going. And so this is a transaction from a relatively new Russian darknet market called Nova that I think is likely being used to pay out to a vendor. You can pull up OXT if you're signed in. You can search through some of the public directory entities that we have, which I guess I probably should just show. And you can see we've got a list of some of the darknet markets here. So in this case, I had gone to Nova and I had basically picked a random transaction ID and then began exploring the graph from here. And so what you can see is on the left side of this screen from the transaction page, there's a display the transaction graph visualizer, which just opened up the visualizer here. And when I get started with an analysis, usually one of the first things that I do is display the transaction details in this little pane. This shows the amounts involved. And now with OXT's new fingerprint mode, I also usually turn on the transaction fingerprints. And so we'll fully expand this transaction by double clicking. And what we can see is, a visual representation of these 4 inputs and 1 output. And with OXT's new fingerprint mode, we can see a few different attributes here. The first is these native SegWit inputs are this light blue color. The pay to public key hash output is a yellow color. And then each of the spending transactions has a slightly different fingerprint, different version number. So if we hover over this transaction, we see that the version number is 2 and the lock time is set to basically the block height. Going to this transaction, we've got version 2 and a lock time of 0. And going to this other transaction, we've got version 1 and a lock time of 0. And so the version numbers, I believe, yes, the version numbers are represented by different shades of gray. Version 1 is darker than version 2. And the lock times are represented by different shapes for the transactions. So in this case, lock times are squares, and lock times equal to 0 are circles. And so I'm going to leave a comment here, potentially hide this, but this was our starting point. and we'll hide that for now. And as we go, I'm going to highlight the outputs, or we're calling these, mark the outputs that I think are controlled by the same wallet. I'm going to hide them for now. And what we'll do at the end is toggle that on and off to sort of help highlight a little bit better what it is that or how we've sort of tracked the same, likely wallet over multiple transactions. So going forward, I'm going to double click and expand this transaction. We could also selectively expand inputs and outputs by hovering just to the right of the TXOs in the transaction detail page. But I'm just going to double click and we'll see how this starts to progress. And so what we can see here is we've got another transaction that creates a multi-sig output, this dashed orange line, and another P2PKH output. If we apply our different script type heuristics, then this pay to public key hash output is the likely change. And so we'll continue to follow this output and see if we can't notice a bit of a pattern. So again, another transaction that creates an output for a P2SH address, this light blue dashed line, and another P2PKH output in yellow. And so we'll follow again the P2PKH output by applying that different script type heuristic. And so now we've got a handful of transactions, each with a lock time equal to the block height in version number 2. Each of these spending a P2PKH output, right, which we can start to deduce is probably the fingerprint of this potential vendor's wallet. And so we'll continue. And now we come to a transaction that has 2 inputs. We've already got one of those inputs expanded. There's another input here. And if we apply the unnecessary input heuristic to this transaction, what we'll see is that this 0.039 Bitcoin output is likely the payment. We can also apply the different script type heuristic here to help deduce that this is the likely payment, because the 0.039 amount is more than both of these 2 inputs. So these 2 inputs had to be combined by this wallet in order to make that spend. And so now we have the choice of either following this change output forward or traversing back up the graph to follow the previous history of this likely wallet. So what we'll do for now is we'll go forward. And in this case, we've got a transaction that with 2 outputs that are still currently unspent. Both of them are P2PKH outputs. Both of them are for relatively similar amounts. This transaction is relatively ambiguous. If one of these outputs had been spent, we might be able to investigate that. But for now, this is a bit of a dead end for us. So what we'll do is we'll go back to traversing back up the graph to continue to look at the history of this wallet. And what we see again is another 2 input, 2 output transaction, similar to this previous one. Again, we could apply the unnecessary input heuristic here. Again, the 0.03 roughly Bitcoin output is the likely payment, right? It's even to a different script type. And again, we have 2 inputs that we can continue to traverse back and continue to search for this wallet activity. When we are traversing the graph for transactions with only one input, we really don't have a decision to make on which output. We don't have a decision to make on which input to follow since there's only one. What we do need to just be careful of is a different fingerprint that might be sort of the end of this transaction activity. So here we come to another transaction that's spending two inputs from the same address. And this input is spent by a different fingerprint here. So this is likely not the same user. And if we look in our transactions detail tab, what we can see is that this is actually another withdrawal from the Nova Darknet market. So this is likely another vendor payout here. And again, we can see that different script types here and a similar sort of fingerprint to this original transaction that we started with. So we'll look at the other input to this transaction, and we see a single UTXO spent. And this is likely some other service that was used to pay to this address. This address may be, another darknet market, but because it's not included in this cluster, and it's just a single output spent, we can't really, know. But this is sort of the end of this this part of the graph. We can't traverse back any further. This other, relatively large output is spent to buy a software with a version 2 and lock time of 0. That's different from this version 2 and lock time of block height that we've been tracking. And so let's toggle now the highlighted addresses. And we can see where we started, went forward again, and then back up to this point here. And what we can, continue to do is applying these heuristics to this, potential input as well. So again, another 2-input transaction. We could apply the unnecessary input heuristic here. And we also have the different script type heuristics that can be applied. And again, we've got now 2 inputs to follow back with. Again, all of these are still version 2 and lock time equal to the block height. So now we've got a single transaction or transaction with a single input, which makes things a bit easier for us. All of these are still pay to public key hash inputs. All of these are still lock time equal to the block height in version 2. And we get to another reused address. This happens to be, this input happens to be a withdrawal from another Russian darknet market, OMG market. This cluster is relatively, young. There may be a secondary cluster with this market that it just hasn't merged with yet. But we'll just keep that in mind for now. So another withdrawal from a darknet market. And another single input spend. This time from BitSlotto, which is a sort of an OTC peer-to-peer marketplace popular in Ukraine and Russia. And so we've kind of come to the end of this, this line as well. I actually meant to add a note to this one. We'll add a comment. Need to highlight these outputs. And we're back to another single P2 PKH input in version 2 and block time, block height transaction to take a look at. Toggle this back off. Again, only a single input here, so no real decision to make. This transaction is a spend to Binance. So we're going to mark this because this is pretty bad. And we'll continue with this graph traversal first, but we'll revisit that Binance address in a bit. Okay. So now OXT has expanded, automatically expanded the inputs to this transaction, which are linked, which sort of reorients the graph a little bit. So we'll have to get situated again. I'm going to turn back on the comments for now, just so that we can see where we've been. Again, this was our start point. We went forward along this part of the graph, then back up the graph to this point number 2, another NOVA withdrawal. Then we went back up this part of the graph to another NOVA and OMG market withdrawal. And now we've been traversing this part of the graph here back to this transaction. Okay. And so now we'll inspect the inputs to this small cluster. And expand them, just so that we can see this is another set of spends, possibly or probably from NOVA, but again, at least associated with Darknet markets. This is probably another withdrawal payout, though this is not clustered with the rest of NOVA. If you look at this, we got another NOVA withdrawal and a relatively small cluster here, which we may be able to continue to traverse. But we'll add another note here as well. And again, continue traversing this part of the graph. Turn off comments. Another small cluster. We can apply the unnecessary input heuristic again for this 0.0096 Bitcoin amount. This may be a payment. Yes, it is a payment. And let's take a look at this cluster. It's an anon, which OXT assigns to clusters. And we can give these anons names if we either interact with the cluster or see any information that might tell us who this wallet may be. In this case, we'll look at some of the activity of this cluster. A very high number of inputs relative to outputs. These are daily volumes. Not much pattern here to see. Addresses, UTXOs. But one thing that can be pretty helpful is the temporal pattern of when the outputs associated with this cluster are spent. We see a peak activity range for this cluster between about 9 a.m. UTC and 9 p.m. UTC. And if we come back to our graph and we look at NOVA, we might be able to compare some of that and make some assumptions about this entity as well. So if we look at NOVA's activity, again, many more incoming transactions to outgoing transactions. And we'll just quickly look at the temporal pattern again. Shows mostly peak activity again about 9 a.m. to 9 p.m. UTC, which is very similar to this cluster. This may not be a darknet market, but it's probably another Russian entity at the very least, or Russian-related entity at the very least. So where were we? So this was a payment. This is a different fingerprint. Not sure we want to go that way. And this is a withdrawal from this entity. So this was a change output. This was probably, okay, yeah, this was a reused address. So I don't think that the wallet that we've been tracking controlled either of these inputs. This was a spend from this cluster. So I think that will stop that one there. And so I think that just about stops the graph traversal that we can do for this entity. And the only thing left to sort of revisit is this Binance address. And for anyone who doesn't know, Binance gives out static deposit addresses. Each one is assigned to basically a single user. So any payments into and out of that address are now potentially link all the related blockchain activity for that address. So we'll take a look at this address briefly and see if we can't figure out who this might be. So this is another deposit to this address. We'll again open the transaction graph and just briefly traverse back. This was our payment. And if we go back to hops, we see another, reused address as inputs. Again, this same anon cluster and a Nova withdrawal. So let's take one or two more looks at some of the activity with this Binance address. Another deposit. In this case, 2 inputs and 2 outputs. A reused address. OMG market. And this transaction was a Nova payout. So we're starting to get a bit of an idea about this Binance address. It's definitely related to, Russian darknet market activity. And if we recall, Hydra market, I believe, was shut down on either April 4th or April 5th. If we go back to just before that, might we see some Hydra activity? And we do. So while we don't know who controls this address, if it's directly controlled by this potential vendor or it's the vendor paying to someone else, we do know that this address, frequently receives from, this part of the transaction graph. And so I think that just about wraps this up, this part of the graph traversal. We'll toggle on and off the marked UTXOs, and you can pretty much see how those P2PKH addresses all stand out. We didn't really inspect the future spending of some of these outputs. There may be additional clues here, especially if some of these addresses are reused, but really this this Binance address is a killer. Let's see. So I think that's probably a good place to stop this. I'll bookmark this transaction and maybe talk a little bit briefly about some of the other features in the tools panel that have been added. there's a mark transaction button now that we are using to basically export information to CSV or JSON. We've also got a screenshot button as well. And last but not least, the bookmark button. And so I'll title this Streetside Session OXT mode. And drop this in the chat. And that's probably a good place to open it up for questions.
I think one thing that would be kind of cool, Ergo, is if you turn off fingerprint mode so that our users can see what a big difference fingerprint mode actually makes in visually being able to track the wallet activity.
Yeah,
go ahead.
Yeah, so I've just toggled it on and off. And when OXT was created, I mean, Laurent will tell me the exact date, but sometime 2014, 15, maybe, I might have been the first time I even heard of it or started playing with it, right? But back when, if we go back to that slide that I showed when we started, before SegWit was introduced, there was almost no need to even have a fingerprint mode. The only thing that really mattered were the amounts and the relative line weights. But now that the Bitcoin network has continued to soft fork in new features and introduce new script types, this fingerprint mode really shows just how applicable that different script type heuristic can be, right? So just toggling between fingerprint mode on and off really reveals a lot of information. And so even if you sort of stumble on this without knowing what these outputs are they public key hash? Are they native SegWit? It doesn't really matter. You can just see kind of natively. These yellow lines are probably all the same wallet. All the nodes on this graph are all the same as well. So we're probably seeing the same entity making many payments.
Thank you, Ergo. I think I can speak for everyone when I say we're very happy you're working for the good guys, as opposed to Chainalysis black box. And if you guys are new here and you don't understand why we're doing this, we call this self-defense chain analysis. If you're unable to review your own transactions and audit your own transactions to see where your weaknesses lie, you're working at a disadvantage. There's an information asymmetry there, where the black box chain analysis firms have this information and you don't. So OXT's entire mission is to give you access to the same tools that your adversary has, so you can build up your self-defenses. And that's what Ergo and Laurent do every single day, is figure out ways to make it easier for you to audit and review your activity on the blockchain. So I guess we can open up to questions, right, Ergo? If anyone has any. I don't believe anyone is force muted on the chat, so you can speak if you want, or you can drop a question into the Telegram chat. I think you stunned them, Ergo.
Yeah, or they're all asleep.
Wow, that's a first. No questions.
I see 5 people typing. There we go.
Okay.
Why did SegWit increase accuracy? Yeah, I answered that a little bit later. That different script type heuristic now becomes much more applicable. Every new script type only sort of serves to potentially enhance that different script type heuristic. Back when it was only basically pay to public key hash addresses, that heuristic didn't apply, right?
So Constantine has a question. What are some steps this user could have taken to better secure their privacy? Coin joins at what point?
Yeah. The first thing is to use a wallet that will do a little bit of randomization against fingerprinting. So there's two sort of trackings to defend against. One would be sort of the automated tracking, which is how we sort of introduce this problem in those sort of academic papers that are coming down the pipeline. That fingerprinting, those fingerprinting breaking heuristics, like typed scripts, randomized chain positioning, and a few other things can be applied by the wallet, by default. Very few wallets do this. Samurai implemented this, some of these defenses a long time ago. So one thing would be to use a wallet that will do those automated, best practices for you. The next thing would be obviously to break the link between your past history and your future spending with a coin join like Whirlpool. So even if someone like me gets a little nosy, takes a look at some of the darknet market activity, pulls up a withdrawal. That withdrawal is, we'll just say, 1 or 2 hops from a Whirlpool mix. And for the most part, that ends my analysis. I can no longer track the forward spending of that user. Right? So that would be another big thing. And then probably last but not least is to avoid Binance or any exchange that basically forces you to associate all of your transaction activity by that forced address reuse. So, using a wallet that has sane defaults, coin joining to establish forward privacy, and avoiding that address reuse are some of the big steps.
Absolutely. Mickey asked, is it possible for this tool or something similar to be made available for people to utilize with their own full node? I'll take that one. The short answer is not OXT. I believe there are other types of tools that you can explore to run with your own full node. The way OXT works is a graphing engine. You almost certainly don't have the hardware required to graph this. And just to put it in perspective, when we moved OXT to new, beefier servers, we started that process, and it took over a year to graph everything out into this graphing engine that you see. So the short answer is no, but OXT is available for anyone to use, and you can access OXT via a Tor hidden service if you're worried about associating an IP address to your querying activity. Let's see. DevFDO said that fingerprint mode is awesome, although I observed that squares were earlier used for unspent output, and now it can be confusing with lock time. Yeah, I understand your concern there, and maybe Ergo wants to chime in, but I'll just say when you're in fingerprint mode, consider it a completely different, wipe the slate clean. The concepts are different there. And there's a lot of different permutations that can happen with a type of transaction, fingerprint lock time. And, we had to get creative on how we denoted these things. So there's always so much you can do.
Yeah, I mean, first off, diamonds, I know it's a square rotated 45 degrees, represent unspents. And that's probably what Dev FD0 is thinking of. They'll be empty, and let me pull it up on the graph. It's still here. Right, these two outputs are diamonds. technically black or with no shading. And again, with or without, fingerprint mode, these are still kind of the same. So it's just something to, just get used to. And by spending a little more time on the graph, you'll start to be able to pick that stuff up.
Definitely. There was one I forgot. Wild Snow. Wild Snow says, I'm still trying to figure out what's happening on the screen. What we'll do, Wild Snow, and maybe someone can beat me to it. We do have a 4-part medium post series that kind of will introduce you to OXT and what's going on here, and you can read that at your own pace. And I think after reading that, you'll have a better idea of what's going on. We also have on our YouTube channel, a intro to the Bitcoin privacy series that will really get you up to speed visually on how to use OXT's graphing engine here, visualizer. So watch those and come back to this recording, which I will put on YouTube, and I think you'll probably be able to follow it a little easier.
Let's see.
QR Cat asks, why the Samurai Mix pool keep information about all user UTXOs, and how secure is this storage? I don't understand what that means. Samurai Mix Whirlpool doesn't keep information about all user UTXOs at all. So maybe a QR Cat, if you clarify your question a little bit, I can answer it better, but I don't understand that question.
Patricio asked, can you share analysis for coin joins, and which kinds of features are observed to link inputs and outputs? We've sort of done this quite a bit. I don't really want this video to run too long. Maybe another time we could do a dedicated, look at some of this. But for now, probably the best thing to do would be to go look at Samurai's YouTube page, where we go over the, let me find it, the DAO hacker. Here. Are there any desktop wallets that use those heuristics that you're aware of? Samurai is great, but curious if there are any options for that may support cold storage. I would say, Sparrow would be probably your best bet, but one of the guys that uses Sparrow will probably chime in and say, no, there's a reason that, like type scripts hasn't been implemented yet. I think I'd asked that recently, and someone had responded with that. So I'm honestly not sure. I think even Bitcoin Core now has like type scripts. Yeah, and I think also Bitcoin Core, but it's really not that fun to use. Let me see, any other questions?
So one thing I'll jump back to on Sparrow, I also don't know exactly what protections that they've included on their basic spends, but I do know that you can perform stonewall spends with Sparrow, and the fingerprint rules are the exact same as with Samurai. So you can't tell a Sparrow stonewall from a Samurai stonewall. So that's one area where Sparrow has taken a very proactive approach in the fingerprinting machine.
AZ also asked, I'm curious about, the Satoshi era wallets. Could we detect those connected wallets which are activated recently? It's interesting to go back and look at the transaction graph from very early on. It was much more peer-to-peer. There were only a handful of, basically centralized services. And it's much more of a different place than what we see today, where everything is really one or two hops from, probably a KYC exchange. So yeah, I mean, you can go back and you can look at that on your own. And let me see.
Yeah, you'd want like type. You would want change output randomization Basically everything that's in Samurai has been in Samurai since about 2016. You're going to want to see that in your newer wallets that are coming out. So it seems most of the other questions aren't related to the presentation, and they will be answered by our phenomenal community, I'm sure, in time. But if anyone else has any questions on the presentation, speak now or forever hold your peace. All right, guys. Well, look, thank you all for attending. Ergo, thank you very much for the presentation. We have to do another one again soon. And do you have any final closing remarks?
No, that's it. Thanks, everybody.
Okay. Thanks you. We will, again, like I said earlier, we will be putting this on YouTube in the next day or so. So see you on the flip side, guys. Take care.